Hi, I'm Bob Luttrell, or Bob the Bee Man. In this film, I'll be running through my system of frames and centrifugal extraction. The previously used systems of honey harvest have generally involved a degree of honey contamination and considerable bee loss. Seeing this for the first time in 2006 made me resolve that the concept was just not reconcilable with my training in animal husbandry and food science. Some individuals have made serious efforts to make a difference to lessen losses. Their numbers and influence are limited. The view of the international community is clear. We are a long way behind. The system most widely taught remains. It kills close to a day's production of bees and heavily contaminates the honey, a honey that is of very high value and very subtle in its characteristics. I set out to develop a system to collect clean honey by first working through many of the concepts already used overseas in Brazil and Southeast Asia, where the appreciation of high quality and above all clean honey is recognised. Australia's stingless bees have small honey pots and tend to mix them with pollen pots. This makes the use of suction devices that are used overseas largely impractical. So tests moved to various artificial pots, also used overseas. Although our bees will build quite large honey pots, that is only under particular situations. If the cerumen supply is short, they can store more honey in a large pot. At all other times, they resort to the standard 12 ml round pot. Additionally, they do not like a built pot with sidewalls. They use it for rubbish, resin and only occasionally honey. While development of the frames was progressing, I developed what I named the Bee-Right Honey Collector. This is a relatively simple device that punctures existing downward-facing honey supers and maintains their orientation. Here we have a colony to demonstrate the process so the honey can be draining while we work through the frame extraction. The honey super first has to be removed. It is the lower of the two supers. The top super contains frames. I expect this super to contain pollen, which may affect the honey. We'll see. The system works by using a static upwards facing bed of nails to fit the honey super, mounted through a mesh screen in a stainless steel tray to collect the honey away from the bees. After piercing, the honey is poured from the chamber beneath the tray into a jug to ensure no bees or debris has bypassed the system. Then it is bottled. Now onto the frame and the extractor systems. Back in 2013, a set of prototype frames were made and put into colonies. Just one was used by the bees, one with a matrix of square cells. From there, 3D printers were used to test many variations, with the ultimate aim to maximise the honey to cerumen contact. This contact is important because of the known connection between the resin in the cerumen and the storage property of the honey. Finally, a concept was found that was accepted by the two major species of the genus Tetragonula, T. carbonaria and T. hawkinsi. This was the trigger to patent the concept, as the production of stingless bee honey from frames had not been achieved in a similar fashion anywhere in the world. Production then moved to the high capacity and much stronger injection moulding, using the best food grade plastics and a Brisbane-based producer to keep control of the process. The key thing in the frame design is that the cells have no wall, just the outline or skeleton to support the honey pot through the extraction process. Part of the design is to open the pots in the frame below. Not quite 100%, a single puncture operation is used. Then there is the extractor itself. This is unique, the concept based on the very old Gray's Slinger extractor for honeybees. Stingless bees cannot easily be removed from frames and are attracted to the honey. To prevent the bees and any debris from reaching the honey chamber, a mesh screen and cap have been incorporated into the design. With the small amount of high-value honey, the sides of the extractor had to be minimised. A V shape was chosen to direct the honey using the centrifugal force to a maximum effect. Putting an outward slope on each of the two sides to the tanks in the base completes the use of this force. This chamber will hold 500 grams of honey on each side. This honey can be poured directly into bottles for sale due to the cleanliness of the product. No further preparation has been required. There will occasionally be pollen pots. This does not contaminate the extracted honey as the honey does not wash over it. Considerable microbiological testing of the honey collected by this process has been done, and also of honey collected by other methods and from other sources. It reveals a very wide range of microbial levels, some in the beneficial group, but many very suspect. This method collects honey from the whole frame with substantially the same microbial status as that in the uncontaminated honey pot. We can do no better than that. The results that I have obtained lead me to ask serious questions about results of therapeutic values from the past, considering just how the honey has been collected and its potential influence on the residual therapeutic values. Perhaps this is a field for others, but I know that some things that I have found have never been reported. All is just building up in a database from the one publication of data in Malaysia. Questions like storage of stingless bee honey at pantry temperature or refrigeration when very clean versus heavily contaminated honey is considered. There are so many questions to ask. I know that the honey from these frames is as clean as the bees have put it into their honey pots, and that they can keep it at room temperature, as it were. That is my aim, to collect the honey in the same conditions that the bees store it.